Hey guys, I just wanted to do a quick video talking about similar polygons. To start with, for the most part, to decide if something has a similar polygon, similar basically means the same, and the picture you're looking at, we can probably look at them and say, well, they look like the same shape, only one's bigger. Really, that's what we're going to try and verify. So we're going to make sure that they are actually truly the same shape. To decide that, we have to make sure that, number one, all corresponding angles need to be the same. So in other words, when I'm looking at these pictures, I have to say all corresponding angles, which means angles that are similar to one another, or angles that are the same part of the shape. So I can look at this one, and this one's actually pretty easy because angle R and angle R prime would be both 96, and I can look at that and say, well, R and R prime definitely are the same points on this shape. Now, something that they can do to make these harder is they can take the second shape and they could twist it and they could turn it sideways or they could turn it upside down, so that you have to work a little harder to decide what the similar parts are. So again, looking at this, we are calling corresponding angles, so angles that are the same, they need to be the same. So they need to be the same. So now I'm looking at this and I can see R and R are the same, S and S prime are the same, and we can go through the rest of that and decide, and we can see that all the angles are the same. So that's one checklist. So remember, what we're actually looking to do is to check if these shapes are similar. To do that, we just have to look. So looks like all the angles are matching up quite well. So I can say, well, hey, the angles are definitely on the line of telling me that these are similar. The next thing that I actually have to look at is I have to make sure that all the corresponding sides have the same scale factor. We call that proportional, we call that ratio. We can look at it a couple of different ways, but essentially what I want to make sure is I want to make sure that this side length, I'm going to pick ST, and I just picked that one, and this one, which would be the corresponding or matching side, are the same. So to do that, all I have to do is I have to look at finding scale factor. Now, the way I've taught scale factor is as basically being a ratio between an image or a diagram and the original shape. So I'm going to continue with that idea, and it doesn't really matter which one of these I pick as being original and image, as long as for all conversions or all comparisons, I'm doing it the same way. So in this case, I'm going to say that this is my original. I'm going to say that this is my image. So basically, I've picked an image, and I've picked an image, and I've picked an original. So now, when I go down to calculate my scale factor, I'm going to get you guys to really focus on that scale factor is image compared to original. And now it's just simply a matter of looking at that ratio. So scale factor is, and again, really focusing on our units. Our units are the same in this circumstance. So it's 3.75 over top of 2.5. Image, 3.75 centimeters compared to my 2.5. So when I take out my calculator and I divide those, my scale factor should be 1.5. So that's great. I have a scale factor of 1.5. Now, for me to truly decide if these two shapes are similar, I actually have to compare and make sure that all side lengths have that same scale factor. So I'm going to compare a different side length. I'm going to compare P and T. So again, same logic. My image is on the right, my original is on the left. So now I'm going to just turn around, I'm going to take those numbers and I'm going to set up that same ratio and do the exact same thing just to verify. Scale factor is my image compared to my original. In this case, my image had a measurement of 4.5 centimeters. My original has a measurement of 3 centimeters. The units are the same, so I can divide them. 4.5 divided by 3 is 1.5. And because these are the same, I can now say with much more certainty that these two shapes are actually truly similar. To be 100%, I should be actually finding the scale factor for all the sides in this shape. So I should be comparing QP and Q prime and P prime. And all of them should give me the exact same scale factor. It's a repeating factor of 1.5. So the textbook kind of highlights this by calling this a properties of similar polygons. And if polygons are similar, it's saying, hey, the same thing that we kind of talked about here. It's saying corresponding angles are equal, and it says corresponding sides, and they use the word proportional. Proportional basically means that it has the same scale factor. So how are they showing that? Well, they're showing that here with A has a single line and P has a single line in the angle. B has a double line, Q has a double line. So those guys would be corresponding. These guys would be the corresponding sides to each other, right? And we can go through that. You can see the stars and you can see the right angle sign. In terms of their ratios, they said side length, and that's all AB down here. All AB means is from A to B as comparing to P to Q. And it just set up a ratio. Now they set up a ratio where they have picked this to be the original, or this to be the image, and this one here to be the original. Okay, so looking at that, and again, you get to decide where your original, you get to decide which one's your image, as long as it's consistent for all calculations. That's the key. You have to be having that ratio in the same manner, comparing same shapes. So looking at that now, we can kind of decide and calculate scale factors. We can calculate enlargements. We can calculate side lengths. If we know that the shape is similar, well, then all of a sudden we're applying that enlargement rules that we learned prior, or we're applying those reduction rules that we learned earlier. So I could ask you to do things like draw similar shapes, and the same logic here is if I'm going to make it larger, then my scale factor obviously has to be bigger than 1. So if I could take a scale factor of 2 example, and now to draw a similar shape, all I have to do is apply that scale factor and make sure my angles are correct, but apply that scale factor to all my units. So I know my scale factor is 2. This is 2 units here. So this line has to be 2 units times my scale factor, multiplied by my scale factor, which means it's 4 units long. So I have to draw a line that is 4 units long. Same thing happens for this one, for the bottom one. I'm going to take my 2 units and I'm going to multiply by my scale factor. So that 2 is my scale factor, and I have to draw a line that is the same length. And it's going to be the same thing on this side. And then this 1 unit times my scale factor. You notice all I'm doing to make sure it's proportional, I'm simply multiplying every side gets multiplied kind of the same, and as a result I end up with a similar shape because I have applied the same scale factor to all my side lengths, and I've measured the angles to make sure the angles are matching my original. So I can draw similar polygons as well. Hopefully that makes sense. It's nothing new that we really learned, other than you get to choose what your object, what the image and what the original is, to decide to set up those proportional side lengths or to set up those angles. Okay, have a good one, guys.